Okay, some more problems from section 9.2. This is number 27. And we have a function generated, f of x equals the square root of 1 plus x. Okay. Alright, so we're looking at the square root of 1 plus x, or 1 plus x to the 1/2. And the first thing is find the first four terms in the Taylor series, generated by this at x equals 0. Alright, so it's going to be a Maclaurin series. That's nice. I wrote out as a Taylor series, just, I guess, for fun. So first of all, we have to find our derivatives. If we want the first four terms, we're going to go out to the third derivative. So f of x equals 1 plus x to the 1/2, and then f of 0 equals 1. And this is f prime of x, so that's a derivative. And you can't keep these, in fractions, but it's okay to do it like this. It's a little easier to take the derivative using the power rule, but if you kind of remember the fractional form, you could generate that also. Okay, so this would be 1/2 x plus 1 to the minus 1/2, and if I evaluate that at x equals 0, I get 1/2, because it's going to be 1, so it's going to be easy to take that power. This would be negative 1/2 times 1/2 is negative 1/4, 1 plus x to the negative 3/2, but then again that's just going to be 1 to the negative 3/2, so that'd be 1/4, and then when I multiply that I get a positive, and then I get 3 over 8, and again this is going to be just 1, so it's 3 over 8. So that works out easy because of the 0, and then the 1 plus 0 is just 1, and 1 to any power is 1, so we're okay there, so that makes it easy. So these are going to be my derivatives, and this was my general form, and then I could have written without the 0 as the Maclaurins, but I wrote it as the Taylors with the center 0, same idea. So you know this form well, I hope, by now. So that should be all right. Get this up a little bit here. Okay, and then we just simplify it out. So these are all going to be 1s here. Well, actually the 0 is 1, if the 0 was 1 over here. And this is 1, of course. And we put our 1/2 in here. And that's just x. This is x squared, that's x cubed. And our signs alternated. Well, they didn't alternate, but this was a negative, so I got 1, 1/2, negative 1/4, and 3/8. And this was the factorials, the 3 factorial, the 2 factorial, 1 factorial, 0 factorial. So this becomes 8, and this becomes, well, 3 goes into 8 twice, 2 times 8 is 16. So there you go. That's what you got. Okay, so if that's all right. Okay, it's a nice little quiz question right there. Okay, letter B. Use the results found in part A to find the first 4 non-zero terms for g of x, which equals 1 plus the square root of 1 plus x squared at x equals 0. Well, I'm just going to take g of x, which just equals f of x squared. In other words, that's what it looks like. Every time I see an x, I put an x squared, so I can do that in the series. So I'll just take piece of 3 of x squared. So I'll take the series, and every time I see an x, I'll just put an x squared. And they just wanted the first 4 non-zero terms, so that makes it pretty easy. So 1/2 x squared, 1/4, I'll look at this one. 1, put an x squared there, x squared squared x to the 4th, x squared to the 3rd is x to the 6th. I put them in over here, there you can see. Okay? So just substitute it. So I'm using this series as the simplified form, and every time I see an x, I just put an x squared. That should be easy enough. Okay. And letter C. Find the first 4 non-zero terms in the Taylor series at x equals 0 for the function h prime of x equals the square root of 1 plus x squared, and h of 0 is 5. Okay. All right, so h prime of x equals this. And h of 0 is 5, and we want to find h of x, so we're looking for the antiderivative, right? We're trying to find the function h, but we're given its derivative, so we have to find the antiderivative of this. So what we're going to try to do is, if h prime equals this, h equals the antiderivative of that. Okay? So we know that much, and we know that h of 0 equals 5. So if h equals the antiderivative of that, when x is 0, this will be 0, but this will equal 5, so this is going to set this up. All right? So again, h equals the antiderivative of this, but when h is 0, if I go from, when x is 0, if I go from 0 to 0, this is going to be 0, but I want h of 0 to be 5, so I'm going to have to add 5. So that's going to give you this. So let me just take the integral of each of these terms. So here's my function over here, which this was going to go all the way back over here. This was the 1 plus x squared over here. That was the g of x. Okay, that was just f of x squared. I should have probably written out a little bit more of that g of x, so we could see that. So they did tell you that g of x was equal to 1 plus x squared, and I kind of wrote it over here. Note, g of x equals the square root of 1 plus x squared. All right? Okay, so this is going to be the integral of g of x. So then we just take the integral of this or this. All right? With respect to x. So this is what I'm working with. So if I take the antiderivative of this, that's just going to be x. All right? Or, well, I wrote it over here. And we're doing it with respect to t plus the 5. Kind of the way the book did it, using a dummy variable. So this is going to be my 1 t squared, t to the 4th, t to the 6th over 60th. Then we take the antiderivative. Okay? And like I said, this t isn't always necessary. Okay? You can just take the antiderivative of this. And that's going to be x, all right, x cubed over, all right, x cubed, and then over 3, and there's the 2, so that's x cubed over 2. I'm sorry, x, there's the 2 on the bottom. I add 1, I get x to the 3rd over 3. Then here I add 1, I get x to the 5th over 5, and there's your 5. There's the original 8. And then here I'll add 1, so I have x to the 7th over 16 times 7, plus the 5. Okay? And they just wanted the first 4 non-zero terms. So actually I didn't even need this term, because if I put the 5 over here, because this was plus 5, that would be the first non-zero term. Okay, the constant term. So it's 5. And then over here, this is the x, and this is x cubed over 6, and this x to the 5th over 40. So there's your first 4 non-zero terms. Oops, sorry about that. Get this up a little bit. There you go. Okay. So that makes sense. But like I said, if you don't really need to do this t term, you just could have gone straight ahead and, like I said, take the antiderivative of this. Integrate this. Okay. And you get that. Just move the 5 over, and that was actually 1, 2, 3, 4, 5 terms. We only needed the first 4 non-zero terms. Okay. All right. I hope that helps. And if you have any questions on these, just same for class, and I can go over some more in class. These are kind of complicated, I know.